welcome everybody. Thank you. This is our, I want to say, third in our series of training seminars that we've been running as part of MinSoc. Very nice gap in the market that my colleagues at MinSoc recognised, and it's been really nice to organise these. But maybe I'd just like to say a little bit about MinSoc. So we've been founded. Oh, sorry. I should first say I'm Emer Deedy. I'm the General Secretary of the Mineralogical Society. And the society itself was formed in 1876, and it's mostly around the study and promotion of an application of mineralogy across a whole range of disciplines. The main things we do is we deliver three journals, so Mineralogical Magazine, Clay Minerals, and our very new journal called GeoBioInterfaces. And I would say that they are a very friendly bunch to publish with, and publish some really high quality and excellent articles. And I would always recommend submitting your papers there. They also published DH and Z, so the rock Bible to those of us that ascribe to that, and work with lots of other European mineralogical societies to publish. This will let me skip. There we go. We also have a range of special interest groups, so applied mineralogy, clay minerals, environmental mineralogy, geochemistry, geomicrobiology, metamorphics, mineral physics, and VMSG. Some of these are shared with the Geological Society as well. These are really the best way to get involved with MinSoc. You can kind of find the special interest group that is of interest to you and get involved that way. And if you have questions, actually I did notice some chairs and deputy chairs, etc., of the groups are in the chat, so you can pop questions in the chat, and also Kevin and I will be able to answer any specific questions there too. So I guess here we are. I'm just gonna flick to this one because I put my slides the wrong way around. Just if you would like to join the Mineralogical Society, we are, I would say, very reasonably priced. If you are a student, it is free for the first 3 years and then starts at £19 per year. We have a new discounted rate that is just starting for early careers at £30 a year. And then for the rest of us, membership is £55 a year. So that gets you free access to our journals online. Obviously membership of our special interest groups. You're also then eligible for bursaries for travel and for research, and eligible for all our awards, of which we have many. You also get a free subscription to Elements, discounts on books, and reduced rates for various conferences, including Goldschmidt. So I'd say that for the money you put in, you get an awful lot of value out of it. And if you have any questions around MinSoc, Kevin and I will be managing the chat and answering any questions you have. And I guess I just want to say welcome everyone, particularly John Faithfull, who I'm truly delighted that this is happening, going to give us a talk on asbestos. And I must commend the Applied Mineralogy Group, of which I was chair, so I have to, explain that. But John, I think this is something we discussed a very long time ago, so I am delighted that this is now happening, and I really appreciate Applied Mineralogy for pushing this along as well. So with that, I'm going to stop sharing, and if you want to get started, and I note that we have, I would say, the guts of 70 people listening, John, so a very popular topic, obviously, so I will stop now and you go ahead, and very much looking forward to it. I would say, just if you have just a couple of I guess housekeeping. If you have questions, please, while John is speaking, please turn off your mic. Feel free to leave your cameras on or off, whatever you prefer, that's fine, as John will be sharing his screen. If you have questions, please put them in the chat, and Kevin and I will manage that. And as John has here, he's got lots of time for questions, so there's loads of scope to ask things. But if you wouldn't mind not interrupting while John is speaking, that would be most appreciated. And a reminder that this is recorded, and that it will be accessible on our YouTube channel afterwards. Okay, John, hand it over to you. Thank you.
Well, hello, and it's very nice to be here. First of all, I'm going to apologise for the technical problems that laid me out last time. The power cuts on Mull are definitely a thing. Last week I had a 31-hour power cut on Friday from Storm Eowyn, and today luckily the weather is fine, and so we seem to be here. What we're going to do today, I've got a wee structure there. one of the issues about this, it's a very big area, and this is actually by far the shortest session on this I've ever done in 2 hours. So we're not going to be able to cover everything. It's going to be an introductory kind of thing, and hopefully something that might light a flame to lead to some mechanisms for making things happen at the end of it. And that's primarily my hope as an outcome from this. The talk is, or the workshop is roughly in 4 bits. And what I'm proposing is to have a wee kind of break between those. So if you've got things you want to put into the chat questions, you can do that. If you want to go away and have a cup of tea and not miss anything, you can go and do that as well. And the exact timings are flexible, but hopefully at the end we'll have something like half an hour where we can get together and talk about this, because that's really the key thing that's going to make good outcomes happen. Currently, I think there are things happening. They're all happening in a very isolated and individual way, and that's not the kind of way we need to develop open, peer-reviewed, good practice science. So making this much more of a community thing is, I think, the key outcome I would like to see. So here we are, the title of the talk, Asbestos Regulations and Geological Materials. Eamar or Kevin said it was popular. Well, I'm not sure asbestos is ever quite popular, but clearly there's enough frighteners being put on enough people that it's seeing that it's cost effective to perhaps take an interest in it. Asbestos is perhaps the ultimate safety bogeyman, hence the slide here. And it's a very large and complicated topic with an enormous amount of regulatory and scientific stuff that you could potentially cover. This is not going to leave anybody as any kind of expert on this. So I'll just manage expectations at the beginning there. I've probably spent more time reading, thinking about and speaking to people about this than most people, certainly in the UK. But I don't regard myself as an expert. I perhaps regard myself as something more like uniquely bewildered rather than expert. And I think at the moment we have generated some simple solutions to some simple issues, which can cover quite a lot of work with quite a lot of geomaterials. But we have no definite solutions for some really important kinds of work with some really, really critically important geomaterials. And these urgently need the attention of academic and industrial geocommunities, working with health and safety professionals and others and legislators to get accepted good practice in place. So, like all things, when we're looking at risk, when we're looking at asbestos, we need to know what we can do safely, how we should do it. We need to know what the thresholds for that safety are, and we need to know what we shouldn't do. Where there are things that are unsafe, we need to be able to decide how can we make these safe. Can we make these safe and meet regulatory and general good practice principles of how to proceed? And how do we decide and who makes these decisions? And as with all health and safety, there are specialists involved, there's an organizational role, there are managers, and there is basically everybody. So there's a kind of information flow and training aspect to all of this. And currently, most of these areas on this slide are not adequately defined or even present. So there's quite a lot, I think, that we need to fill in terms of developing good practice. Industrial use of asbestos has caused huge health damage, and obviously we kind of assume that everyone in the world, asbestos is an old-fashioned thing, perhaps, a historical thing in Britain. But many legislations around the world haven't actually banned asbestos, and there's still an enormous amount of asbestos mining and production going on around the world, in, for example, Russia, India, China, and many other countries. And in places like Britain, however, almost every aspect of asbestos' existence, management, and use is extremely regulated. But it is a natural material, or it is derived, the industrial products are derived from natural rock materials. And it's an issue that industrial and academic and research geoscience has kind of been avoiding. Now, this is not necessarily just our fault. People haven't, up to now, made it a big issue. And this may partly be through a belief that it isn't a big issue. This is probably true in that there's not an obvious huge cohort of asbestos-related disease and death related to geologists working with rocks in crushing labs. But that doesn't mean there's no risk. And the other reason why people, in fact the main reason why people haven't addressed it, is I think fear of the A word and fear of what we might need to do or stop doing to comply with this. Now, all of these are terrible reasons for not thinking about an issue. And over the past decade or so, a kind of slightly slowly increasing number of us have started to address these issues or been forced to address them. But to date, as I'm saying, actions I think have been very bitty, unconnected and incomplete. And I think now's the time for us to put some collectively proper effort and resources into doing this right. And as I say, I hope this will start this process. So why is asbestos dangerous? Well, the unique danger comes overwhelmingly from fibre release and inhalation. Solid asbestos presents little hazard unless it releases fibres to the air. And so the fibre release depends on the physical properties of the solid material and the things that happen to it or are done to it. And in some ways, I think it's very useful to think of asbestos as a kind of special case of dust. Almost all forms of dust, airborne dust, are a hazard. Elongate mineral fibres, EMPs is a new one, but wood dust, MDF dust, coal dust, and increasingly in the UK, at least certainly, quartz dust is becoming really quite highly regulated because I think a lot of issues are arising from still saw and dry cutting of quartz-rich composites and kitchen materials and so on. So dust is a general issue, and asbestos is a special case of it that has its own particular legal frameworks. But I think in terms of thinking about safety in terms of dust, that is a generally very useful kind of starting position. Asbestos is an unusual hazard in many ways because it's in many ways a fabulous material. It contains no toxic elements, it's cheap, chemically stable, durable, strong, fireproof, pest resistant, insulating, capable of being incorporated into a huge range of composites, and you can even weave it into trousers and gloves and hats and all sorts of things like that. And it seemed like a miraculous product. And the explosion in its use in the 20th century seemed like a huge benefit. Although quite early on, in fact, even probably as early in the 1920s, it was realized that curious diseases were occurring among particularly women weaving asbestos in mills in Rochdale. Someone called Nellie Kershaw was, I think, one of the first people to be identified as having got an asbestos disease there. But the amazing usefulness of asbestos has meant that there was a real explosion in its deployment in all areas of industry and construction all over the world. The other thing about it is that it doesn't have usually serious short-term effects. So the spotting of cause and effect in terms of asbestos dust, in the short term, it's much like any other dust. But the effects of long-term exposure turned out to be catastrophic, but really only emerging some decades later. If we have a wee look at the UK timeline on this, really until 1983 there were almost no there was no prohibition on using asbestos materials in any materials we wanted in the UK. In 1983 the amphibole asbestos products were banned, and then in 1999 there was a complete ban on chrysotile. And then the main regulations that we have in the UK, this will obviously differ around the world, and I've tried to take that into account in the talk I'm doing today. But the main regulations that guide things in the UK are still the 2012 regulations. One thing that's very interesting to note on here is that asbestos, natural asbestos materials aren't covered by REACH. So asbestos which has not been added to products is not covered by REACH regulations, and therefore is not applicable to the natural materials in this way. I mentioned we still live in an asbestos world, despite the fact that asbestos was banned a long while ago. There's an awful lot of asbestos in old buildings, and as long as it's encapsulated on sealed or solid materials, there's little or no risk. But disturbing these can be extremely dangerous, and hence we all have, in the UK at least, organisations have to maintain asbestos registers, of carry out surveys of the buildings and other places they occupy, and maintain registers of where there's asbestos and so on. Carry out monitoring to demonstrate that workers aren't being, and the public are not being exposed to airborne asbestos from the structures and so on. Any work which might release asbestos dust or fibre needs to assess asbestos risk as part of the planning. And the UK, at least, the legislation and regulations provide really strict frameworks for managing all of this. There are similar frameworks in many other countries, although not all. Canada only really abolished asbestos in 2018, Ukraine in 2023, and the USA full ban only came in 2024. Might be interesting to see how long that lasts. Many countries, including Russia, India and China, do not yet have total bans, as I've said. So the vast majority of asbestos diseases have a very long latency period. So the maximum incidence of these diseases, this is from a 2023 publication from the Health and Safety, I think, in UK. Although asbestos, amphibole asbestos was banned in 1983 and all asbestos in 2000, cases kind of peaked around 2019, 2020, it looks like. So the ongoing problem is very big. It's not just a historical issue. So what is asbestos? Well, it's not entirely clear. Almost all the definitions in legislation are based on a range of 6 kinds of industrial mineral products, which were widely used across the world. The 2012 regulations in the UK define these on the basis of the Chemical Abstract Service kind of compound numbers. So they don't actually define anything in any strict mineralogical way. And the use of these particular products kind of maps only rather loosely onto mineralogical nomenclature, and anyone who knows about amphimold nomenclature will know that that's a particularly thorny and intractable kind of area of compositional space. So we have a problem in terms of, we have zoned crystals almost universally. So we were characterizing things simply as being one of these products is really very difficult or impossible or often inappropriate in terms of assessing the risk arising from geological samples. The other issue that we have is that the use of fibre and fibrous in regulation, these are very subjective terms, and we often use fibrous as a kind of hand specimen habit descriptor in mineralogy, and we can quite often use fibrous for things, crystals that are a millimetre or two wide, which is orders of magnitude wider than an asbestos fibre. But I think the confusion about what fibre means, or the kind of ambiguity in terms of what fibre means, is another thing which we have to be aware of when we're looking at these issues. As I say, we have these 6 products with these kind of names in terms of the amphibole, asbestos and chrysotile asbestos, but there are amphiboles, obviously, there are asbestos issues that arise from products out with this space. There are things like richterite and winchite, which have been associated with very severe asbestos disease things in places like Libby, Montana, where vermiculite was produced from an altered alkaline complex, and the vermiculite was intergrown with acicular amphiboles, and those acicular amphiboles have had a catastrophic effect. There's a great deal of fibre released during processing and handling of these materials. So although these other kind of amphiboles were never produced as industrial products on their own basis, they have been causing disease for issues. So I think it's generally better to not worry too much exactly about the identification of amphiboles, but to have for us to be thinking in terms of exposure to asbestiform amphibole as being the issue, rather than worrying particularly about whether it's these things. There may be other minerals which are also a problem, which are not covered by legislation. One particular one, which some people may have heard of, is that there's a zeolite mineral called erionite, which occurs in various geological settings. It occurs at tiny amounts in kind of specimen type zeolites in basalts, including in Skye and other places. But the main hazard comes where you have loosely consolidated zeolitized tuffs and litharonites containing large quantities of ultra-fine grained fibrous zeolite erionite. And in Turkey in particular, in Cappadocia, windborne exposure to these materials is associated with quite a lot of asbestos disease, even though it's this erionite that's causing it. So again, this is another reason why thinking in terms of these 6 industrial products as being the hazard we're trying to mitigate is, I think, not terribly helpful. And we're thinking in terms of a broad exposure to dust, which may be hazardous, and particularly to fibrous mineral dusts, which we want to try and minimise. So where does asbestos kind of come from? Well, just a quick scoot through some of this. This is the Thetford mines in Canada, which are one of the biggest Canadian producers. These are from a Taconian ophiolite complex, and they overwhelmingly produced chrysotile asbestos. And if you look at the kind of places where people live around the Thetford mines, and these are nice little rows of wooden houses, and among huge piles of low-grade asbestos waste, chrysotile and all sorts of other things in those. Rather curiously, there's not a terribly high incidence of environmental exposure asbestos around Thetford. And it may be something to do with wet climate and relative abundance of vegetation, which stabilises soils, I'm not sure. Other place here we are, Whittingham in Western Australia. There's a blue asbestos deposit, as cross-fibre veins in Lower Proterozoic Biff. Quite a lot of the mining companies working in the Pilbara and so on have to watch out for this, because these giant mining operations are quite often dislodging and having to work through materials which does contain these blue amphibole veins. So the industrial documentation that's associated with these is actually, as we'll come to later, a kind of interesting and perhaps potential area for resources here. But a particularly horrific example of workers having a wee competition shoveling dusty blue asbestos into drums. I would doubt that many of them are alive today. Similarly, the same kind of rocks found in not all banded iron formations contain these cross-fibre sodic amphiboles, but particularly Cape Province in South Africa and Western Australia and one or two other places around the world had the same. And the asbestos was mined extensively in South Africa, and it caused huge problems for the miners, and it still causes today, as you can see from these loose piles with felty blue asbestos lying on a dry, unvegetated surface, enormous health problems for people who have to live in these environments. This is the famous Libby, Montana vermiculite deposit, which sounds like a harmless material, but this particular vermiculite was intergrown, as I say, with amphiboles, and has been a really, really serious cause of asbestos-related diseases from that. And indeed, also, there are chrysotile and other asbestos exposures completely natural. And one of the most interesting one is Sumas Mountain in Washington State in United States, where a very large landslip on the side of a mountain has, which is moving, and therefore there's a lot of bare soil and rock exposed on the surface of it, is very rich in chrysotile. And there's a lot of chrysotile going into watercourses. Rather curiously, the epidemiology of this event suggests that there is no excess of asbestos-related cancers from this kind of environmental exposure. And in fact, in terms of asbestos diseases, the Whatcom County, where this is, has a lower incidence than other places in Washington. So the hazard arising from these things varies quite a lot, and we really don't understand this. I think I would say it's the exact epidemiology of these things remains a bit mysterious. So asbestos or materials are usually associated with metamorphosed ultramafic rocks and ophiolites, some banded iron formations. We can have asbestiform amphiboles more rarely in calcium-rich and mafic rocks, including some marbles. Some tremolite marbles occasionally have some asbestiform material in them, even though it's normally more coarsely crystalline. But you can also get asbestos materials in low-grade pampelite to green schist metamorphism, and this can often be a later retrogressive phase on higher grade assemblages. So, for example, in the Lewisian in northwest Scotland, you have nice granulite fascies, basic and ultra basic assemblages in TTG gneiss terrains, but there are small amounts of retrogression in some of these, and some of the serpentinite bodies, which were olivine rich, do have chrysotile veins and so on in them. You can also get asbestiform minerals developed from hydrothermal alteration, shearing and myelinization, fracturing and brecciation of appropriate starting materials. An interesting kind of slightly lesser or rarer of thing is that sometimes phenites and low temperature alkali metasomatism, and there are blue amphibole phenites along the shores of Loch Ness, actually around the Breachin and other places like that, which contain traces of these kind of things. So there is a diversity of places where these things can occur. There are also, as I say, these hazardous zeolites, which particularly in terms of dust release, zeolitized tuffs and loose volcaniclastic sediments are particularly the hazard. It appears that erionite is by far the most serious of these, and other fibrous zeolites don't at the moment seem to be particularly dangerous. But erionite is a really, it may be worse than blue amphibole in terms of triggering asbestos release responses. In terms of relative risks, by far the biggest amount of risk that we have from asbestos comes from occupational exposure to known industrial asbestos sources, including mine wastes. But there are deaths attributed which we don't really know where the things coming from, and this may include low-risk occupational or natural exposure to asbestos. If you're a member of the public, it's quite easy to answer the question, do I have an asbestos problem? You phone up an asbestos lab, of which there are many around in the UK certainly, who are licensed and capable of identifying the 6 industrial products. They will come along and take surface swabs and or air samples and or material samples, depending on what you want. And they will then examine these. Primarily, the main tool is polarized light microscopy, using some slightly different things which most of us as mineralogists and petrologists won't use. Dispersion staining objectives and phase contrast microscopy are used quite a lot. But the interesting thing about seeing an asbestos lab is that you kind of imagine everyone's going to be wandering around in breathing apparatus and suits. The whole point is that if you're doing that, you're releasing fibers into the air, you're doing it wrong. So everything that they do is done in benchtop negative pressure cabinets, which draw air in and have suitable HEPA filtered filters on the back. They're not plumbed into the building, so they just sit on bench tops. And in these, you can carry out microscopy, you can carry out sample cleaning, you can carry out transfer of samples from bag to bag. You can clean things with baby wipes and other things, and then bag all those up inside the material, double bag those for later disposal as asbestos waste. So actually seeing how asbestos people work and manage these things is really, really interesting. And I think these kind of approaches give us, I think, an indication of the kind of tools which are relatively cheap and easily available for perhaps helping with some of the issues that we might be identifying. However, if you're a geologist and you go, well, do I have an asbestos problem? Yes, sometimes the answer may be obvious, so you might be fluffy, silky, flexible, finer than human hair, splits along fibers rather than across fibers into little blocks. So you can do a certain amount with your eye, but often it's not obvious. So you come to a kind of road cut, or you look at some dusty rock saws. Asbestos fundamentally is as natural as bunnies and flowers. How can we tell? As I say, using your eyes, visual risk assessment all the time is a kind of good thing to be thinking about. Here's some serpentinite outcrops from Shetland. You can see those both have little cross fibre veins with chrysotile in them. Some garnet specimens from Italy. Those little white bundles of fluff on the top are asbestos. Here we have some Lewisian and some lizard serpentinites. How do we decide whether those amphibole crystals at the top, which we might broadly describe as fibrous-ish, are those asbestos or not? How do we make decisions about how we work on these kind of rocks, which are a really huge and important part of investigating the Earth's crust? We look at thin sections of serpentinites. You're allowed to chuck asbestos waste away as not asbestos waste if it contains less than 0.1%. How do we know whether a serpentinite contains less than 0.1% chrysotile? That's almost below the detection limits for XRD, and there's no other way really of knowing. These asbestos labs don't have any experience of dealing with geological materials, so it's a kind of very difficult and unanswerable kind of question to deal with. You've got little serpentine veins here and some altered olivines. What is the mineralogy of those? Do we need to worry about those? Here we have some elongate amphibole in a thin section. We would describe these as fibrous. That doesn't necessarily mean asbestos. I mean, I think you can see in these fibres, particularly the cross-polar at the top, that there are a lot of fractures going across the length of those crystals. So they're not splitting into kind of nanofibrils, if you like, or anything like that. They're breaking into small lumps. But how do we assess these things before we hammer, saw, grind materials to make sections? So the characterization of geological materials is extremely non-trivial. That's, geologists, we spend our life getting good at this or trying to get good at this. And it needs resources, techniques, technical access to instrumentation and expertise. There is no one else who can do this. You cannot go to a local asbestos lab and expect them to, they will know nothing about rocks. So I think health and safety professionals recognise that they rely on our mineralogical and petrological expertise, and there is no way around that. So we are the best people to be working on this, and we are the people who understand the materials best. It is up to us to work out how perhaps we can do this. And in terms of how we do this, we need to, I think in terms of a kind of field to lab scale. One or two places, as we'll see later, have done this, and I think one of the problems was a student may have inadvertently brought into the building a very large amount of seriously alarming blue asbestos this raised the issue as something which they did need to provide training and mitigation in. But in general, characterizing geological materials is difficult, and it's up to us to do it, and it's up to us to do it safely. The characterizing is perhaps a much lesser issue than general large-scale breaking, cutting, crushing. We're talking about fibre release. These are the big-scale things that release fibres. So rather than becoming too precious about tiny, small-scale things, we need to be looking at rock dust release in general and assessing hazards on all these kind of scales. Ornamental stone cutting and polishing is a huge issue, and I noticed there were some people from Italy here, particularly Italian geologists, who've done a lot of work on this in terms of serpentine marbles and things in the Alps and elsewhere. These are areas where I think there is practice in some places in the world. Quite a lot of the detailed practice may be in other languages, and I think this interchange and kind of bringing out little islands of information and knowledge that are there is one of the key things that we need to develop. The Health and Safety Executive actually produced a really, really useful recent document on asbestos in some kinds of marble and other stone relating to ornamental stone. And I think this might provide a kind of prototype in terms of what I would like to see in terms of good practice for, if you like, geological investigation of natural rock materials or something like that as a long-term outcome which will provide the good practice we need. So in terms of what we do, well, rock crushing for geochemistry seems to me a big problem. We've got kind of TEMA and shatterbox mills. We've got various kinds of jaw crushers and fly presses and so on. All of these seem potentially things that can release fibres. Those could be a hazard. They are also, I think, in terms of releasing dust into things, they're also an analytical problem. And when we have part per trillion analytical capabilities, it matters that very small amounts of dust have been left by one person from one particular rock and another. So I think perhaps also thinking a bit more along kind of clean lab lines may be another way forward in addressing a whole lot of issues and providing benefits more broadly rather than just seeing asbestos as a standalone problem. Rock cutting and sectioning is similar. That's one of the huge advantages we have, and there's good evidence about this from the Italian work in the stone industry, is that we always cut underwater in labs or under fluids, and this has an enormously beneficial effect on reducing dust and an enormously beneficial effect on reducing asbestos exposure, almost to the point where it may or may not be an issue. Of course, you then have the issue of what happens to dry dust in spaces and so on, but this is another area where I think we need to look at. So how do we carry out risk assessments when working with natural materials? How can we work safely and effectively with geological materials? What do we do when we identify that a base risk threshold has been exceeded? How can we work with those materials? We need to be able to train others to use these materials. We need to be able to show that we can safely use materials which may have been identified as being hazardous. There are resource and funding issues for us. And in terms of legislative practice, for naturally occurring radioactive materials, there's an exemption in UK law called NORM, naturally occurring radioactive materials, which means that some radioactive regulations, not all, don't apply to natural materials. And it might be worth looking whether some issues might apply to some aspects of this for natural rock materials as well. But these are things which we'll tease out a wee bit later. So I'm going to have a wee rest there. I've probably gone a bit slower than intended. If you've got questions and things that you want to put into the comments, you have a couple of minutes to think about that. And what's it, 15:42? Start again in 3 minutes' time. We'll deal with all the questions at the end. But if you want to put things into the chat box, and then Emer and Kevin can kind of collate those, and when we get to the discussion at the end, we can see how those are teased out. The next bit I want to look at is a relatively short section, but having a wee look at some case studies and what we can learn from the experiences of others. One of the obvious things is literature, but there is a massive volume of literature. I carried out my interest in asbestos really developed around 2013-15 it became a priority in the museum sector, in geological museums, and we organised a workshop with the Health and Safety Lab in Buxton, and I see Laurie, who is here today with some of his team, and it was a really, really useful workshop, and we identified the things that we would like to see happen, but when you have no ring-fenced resources, no ring-fenced time, and everyone just relying on some hope and goodwill, in modern organisations, you won't have time to do these things. In the nearly 10 years since that meeting, relatively little has happened in the UK, and I think that urgently needs to change. But in the 10 years since that meeting, for example, Geological Asbestos Laboratory Protocols gives us 2,850 results. I've not read all of these 2,850 papers, and I'm sure nobody on earth has. One of the surprising things is when you look at these papers and you look at the methods statement, they're mostly rather thin on actually how sections were prepared or how analytical powders were prepared. In fact, I only found one, which was someone who'd done some work on the Libby asbestos, the vermiculite intergrown asbestos. And they mentioned that the material was so hideously dust emitting when it was handled that they did everything in a negative pressure stainless steel box and developed special ways of cutting and mounting and impregnating and so on. But most of these lab accounts don't take account of this. Now, I don't believe that's because people are being cavalier, but I think people are rather nervous or proprietorial, or asbestos, the kind of, the word doesn't, people are unaccustomed to being open and exchanging things with it. And I think there's a massive amount of data about odd things, but I think basic data about fibre release from normal lab activities, there's not very much of that in the published literature. But there is an immense amount of potentially relevant stuff, particularly, as I say, there's a lot of very interesting material from from Italian mineralogists and petrologists looking at industrial asbestos release and release from asbestiform rocks and mine waste in the Alps. And that's, I think, really a key resource. You'll see on there's an identifying and managing asbestiform minerals and geological collections, which by Jana Horak, me and Monica. That was a little paper produced in terms of managing the museum crisis, and I'll say a little bit more about that later. I think one of the dangers about this assessment, the way that asbestos risk assessment and hazard mitigation is kind of potentially going to develop, is that it's very dangerous for individuals to kind of set themselves up as the sectoral expert on this. And I don't see myself as that. That's not what I want at all. It seems to me this is something we all have to engage with, and all good science relies on us reviewing practice, being open about practice, being informed and having data to make decisions. And where there are data gaps, it would be useful to have those filled. And it seems to me this has to be an open, community-owned assessment that if it's going to work, and it needs to be something that we're all engaged with, rather than something which individual companies will charge huge sums of money to descend from on high and solve your problems for you. I think I have a degree of skepticism about how much more they might know about these things than anybody else, but organisations quite often seem to like that as a kind of solution. And I really don't want to see any kind of monopolistic gatekeeping in terms of the development of who can work on rocks. It seems to me that's extremely dangerous for lots of kind of intellectual reasons and human and societal reasons. So it seems to me we want to be open about how to do this right, and we want to develop good ways of doing that. I mentioned the museum sector, and this is the paper that we produced in 2016, which arose out of that. This was a kind of quick response to a potential paralysing crisis that we'd be told we couldn't do anything in the museum sector. So we quickly realised that there were ways of where there is no information, people can throw up their hands in horror and say, well, there could be all this danger. Well, the answering that question is there danger is very straightforward. If you think about how do the public answer the question, is there an asbestos danger? You get asbestos contractors in to do surface and air measurement, and you quickly find that there is not asbestos everywhere, and there is no need to block off whole rooms or buildings just because there's a mineral collection in it, for example. So I think that approach of using the sectoral expertise and getting information to answer questions is very useful. This kind of risk management and how you deal with existing collections which might contain asbestos is something I'll come back on to later. But I think this is part of the thing which is relatively easy, unlike, for example, the crushing and cutting of unidentified ultramafic and other materials that might contain asbestos. And as I say, we'll come and have a look at those wee things a wee bit later. As I said, I mentioned one of the advantages of doing this workshop is that it kind of aroused, people got in touch from all around the world to say, aha, this is very interesting, I'd like to come along, or have you seen this? And I was able to get some new information that I didn't know about. And particularly, Western Australia has some interesting documentation about both from government side and from mining companies like RTZ and BHP and so on. They're producing enormous amounts of crushed rock and moving enormous amounts of material. And they have quite a lot of procedural stuff about how they manage these things. It's more, the ones I've looked at so far seem to be rather lacking in the kind of lab scale things, which are really the key ones for us, I think. And I think one of the things about commercial operations and consultants is that they often see their protocols and practice as perhaps proprietary and part of their intellectual property. So the kind of details are often not circulated in the way that might be helpful to us. There's another one there on the screen from Finland, looking at how asbestos risk is managed in kind of mineral exploration guidelines and so on. And again, we have this kind of zoned risk assessment, which seems to me, like all risk assessment, you kind of think about things in advance, you gather information, you look around, and then you do things in an appropriately safe and modified kind of way, or don't do them, depending on how you identify risk. But that Finnish one was quite an interesting one. But again, it mentions the survey. Are there fibrous minerals in the mining area? How take thin sections and samples. It doesn't say anything about the protocols for doing that. And again, it seems to me this is the area where really we need the practice, and we need the written good practice to demonstrate that we're operating safely. And this is, seems to me, the key kind of things that we need to develop for this and for analytical rock crushing. So to kind of go back to what I might see as the easy bits on this. If you're in somewhere and people go, well, is there an asbestos hazard from all these terrible geological collections you've got here, or this terrible thin section lab? It's very easily answered. Most big organisations, certainly at University of Glasgow where I worked, did routine air and surface tests kind of randomly every year, came round and people would monitor stuff in different rooms and buildings and so on. And if you want to do a special one, they're not particularly expensive. I think the surface test ones were around about 20 quid or something, I think. And the air ones were a little bit more, but not terribly much. So answering these questions is very straightforward. And if you find there's no particular issues, which is probably going to be the case, then you have time and space to think about perhaps other issues and the higher risk activities which you might need to concentrate on. And obviously, if you do find there's a hazard, that's a good thing, because it means that then you can, the scale and scope of the problem can be investigated. It will be good for everybody's health and everything else. If the problem is identified and solved, you can specify and cost a solution. So there is nothing wrong with getting these kind of things done. And I think, you know, rather than wringing hands and spending a very large amount of staff time worrying about issues, spending 20 quid on getting a surface test done is a really, really cost-effective way of answering questions about hazards. One of the things which we mostly geology departments will have is there'll be a lot of existing rocks knocking around, and either in kind of more organised drawers, perhaps in card trays and so on, but also old research collections, which were perhaps petrological and geochemical research collections in boxes in rock stores. And these are an essential resource. You know, most analytical geoscience cannot happen without specimens. And specimens are an absolutely fundamental part of how we are able to look at and investigate the Earth. So not having them is kind of not an issue. If you're wanting to look at those kind of risks in existing collections, this is a kind of thing where some of the museum experience may actually be useful to the wider community. Look at existing information sources. So if you've got a PhD collection, you can read the PhD thesis and see what kind of materials are in there. And that will probably quite quickly allow you to say, well, that's going to be, he was working on limestones from the Bahamas, there's not going to be an asbestos hazard in any of that material. Again, this exterior air testing and surface testing, if you're worried in rock stores and so on. The other thing is training people to use their eyes before doing anything to anything. And lots of health and safety comes down to thinking before you act and using your senses before you do things. And that applies to, whether you stand on a dodgy ladder or whether you, decide, am I going to put this piece of rock into a fly press? So I think the idea that we train rock users and students and others to use their eyes and think about these issues in terms of identifying where the thresholds for fibrous, in terms of asbestos, thresholds versus just kind of normal elongate amphibole. As I'll come to in a minute, it is possible to do quite a lot of that by visual asbestos, visual assessment. So someone who knows amphiboles can look at an amphibole from a distance without handling it and say, those fibrous amphiboles are absolutely not asbestiform. Those ones might be, and those ones definitely are. And that threshold is quite far up the line. And as I say, I did some lab work, which working with an asbestos lab, and produced a scoring matrix for doing that. It requires some mineralogical training or petrological expertise, and we'll come to that a wee bit later. But it is possible to do that. The thing then is, if you find things that look dangerous or look potentially dangerous, that should be a stop. And again, that's a standard health and safety thing in anything. If you come across something that your training tells you shouldn't do, don't do it. And so if you're looking through drawers and boxes, if you come across something nasty, stop, mark it as potential asbestos, move on to the next one, and record the storage location, the drawer or the box in a spreadsheet and whatever. And then you can think about approaches to how you would either dispose of the material if you don't want it, or perhaps how to encapsulate it by double bagging specimens in Ziploc bags and repackaging them so that they can then be used safely. But those are kind of management decisions you can make later. And then having done that, you can then surface sample the area and get an air test done to confirm that the area has been decontaminated. So again, all of this stuff is relatively easily done. Rather than wringing your hands for a long time about these kind of problems, it's relatively easy to do. So again, in industrial asbestos risk scoring, you need to know whether it's asbestos or not, type present, physical form, surface condition of material, the quantity of material, and the activities which might affect that material and cause fibres to be released. Similar principles apply to looking at rocks. So if you're looking at a specimen and think, is it actually marked as asbestos? That would be a flag. Is it already in an existing asbestos register? If you're looking at looking at the mineralogy and the rock type, is it identified or not? So you need a certain amount of training to do these assessments. You can look at the habit, texture, crystal grain size, surface condition and solidity. Again, that's something which requires a degree of mineralogical training and expertise. The size or quantity of the material, potentially asbestiform material present, and what's likely to be done to those kind of things. And those all, if you like, add to the scoring and weighting of the immediacy of the risk. And this is the matrix, if you like. I produced a scoring method of looking at specimens in a museum, and this is not necessarily the only way of doing it. We found this worked, and we calibrated the scores we got against material by having them looked at by an asbestos lab. So we were confident that these visual assessments would result in anything that might be asbestiform exceeding the visual threshold, and anything which was not unsafe could be proceeded with. And so after going through these kind of scoring procedures with a little spreadsheet for specimen, you wouldn't need to necessarily do this on a specimen by specimen thing, but it's handy to think about this in this way. So what species are present, what's the texture and habit of the species, what's the surface condition and the kind of looseness of the material, and then you can produce a little colour graded score as to whether things need treating as asbestos or not. And it seems to me fundamentally that kind of approach is something which everyone should be doing. You need to have risk assessment built into lots of things you do in life, and training people to think about it as a potential issue which they might need to think about is important. The Curtin University have come up with some draft procedures. These just define fibrous minerals as a thing. I think that's possibly a slightly general term, which I wonder about. Potentially asbestiform minerals might be a better term, because fibrous is just too widely a mineral habit term. But in their building regulations now to help manage some of these, and I think I know other places are as well, and it seems to me this is a good way to think. They needn't be onerous, these things. Quite a lot of these things will be yes, no, that you can answer mentally or on paper or on computer very quickly, and you can say yes, no, and proceed as long as it's safe to do so. The key thing about training is that you cannot handle safely undocumented materials you don't know anything about. If you don't know whether things are toxic or radioactive or asbestiform or anything else, whether it's in a chemistry lab, a physics lab, anywhere, you need to know about the things around you in order to have them safety. So departments need a degree of mineralogical expertise to be able to safely make accurate visual assessments of rocks and minerals, and to train others to do this. Doing this should be provided to all who may handle rocks, including students. So things like toxicity, radioactivity, and dust asbestos, not just asbestos, but dust, should be things that people are aware of when we're training them to work with specimen materials. And in terms, particularly in the UK, actually using asbestos materials in teaching is a very difficult and, well, it may well be illegal. But there's a degree of clarification needed on that. But the photo training of what asbestiform versus not asbestiform amphiboles look like, and where the risk thresholds are, can be, I think, a very powerful and robust tool which you've shown has worked. And telling people always, if you're anxious and worried, when a risk threshold is exceeded, stop and follow guidelines. Don't proceed unless you've been trained and your training indicates that proceeding is okay. And again, this issue of dust control is key. Dust is a real hazard, and asbestos is a particularly nasty aspect of dust. So that's kind of some of the easy bits I'm going to look at. I'm just going to have another wee break for, what time is it now? 6. A few minutes, and we'll have a look at, let's see, was it 6? 4 minutes time, 10 past. If you've got questions or points that you'd like to put into the chat, please do that. Otherwise, if you want to go for a pee or a cup of tea or whatever, do that, and gather again in 3 or 4 minutes. We kind of get to the hard and important and interesting part, if you like. How do we as geoscientists work on potentially and actually asbestiform materials. These are significant recorders of earth processes, and at least some people sometimes are going to be able to need to investigate such materials using existing and new techniques. Those of us who've attempted so far, mostly in the museum sector, to draw up guidelines for legally compliant asbestos risk management have come up with similar solutions to those I've described for the easy bits. So you can identify sub-threshold materials which you can work safely on. The problem comes with where you might identify materials which are in the grey area or above the threshold sort of for safety. And we simply can't be in a situation where those are off limits to any investigation. Altered ultrabasic rocks is most of the ocean crust, most of our planet. Enormous amount of work on serpentinites, from origins of life to carbon sequestration and all of these other things. There are potential chrysotile issues in a lot of those. There are lots of other metamorphic rocks that might contain rather fine-grained amphiboles. So we need to understand these earth processes, not least for understanding how asbestos forms and in terms of being able to inform bigger scale risk assessment in terms of zoning geological units and things like that. So there are lots of reasons why it is absolutely essential that we are able to work on the full panoply of rocks that make up our planet. And in particular, these involve the cutting, polishing, grinding of these materials. Currently, we have a lack of published data on the dust fibre release from geological lab activities. In order to assess risk, you need to take a precautionary approach, but you need to have be informed. You need to have data and information, and we need both of those for best practice. Currently, our health and safety managers and so on are requiring a precautionary approach, but we do not have the information to do that correctly. And any appropriate mitigation and risk management needs information about this. And I think there is not really any way around that. This is a picture I've shown before, obviously, but I think this shows that working safely with small samples is actually not particularly onerous. By using negative pressure vessels and clean lab approach, you can manage all forms of dust contamination. You can work with microscopes and other equipment, small scale equipment inside units like this. And so potentially quite a lot of work with prepared samples and sections and taking aliquots of samples for analytical work can be done in filtered negative pressure or fume cowards or other kind of containment. And this is good for, as I say, all forms of dust contamination control, and it has the byproduct of managing asbestos. And they're not particularly expensive. I think the last time when I bought one of these, which was not that long ago, I think about 1,500 quid, including that. That was a few years ago, but these do seem to me to be quite a good way of working with kind of small samples in some ways. Before I go any further, I'm just going to say this is probably a UK issue only, and it's something that will come up when you're probably talking to health and safety managers or asbestos managers in organisations. UK legislation has a number of classes of how people can work with asbestos, and there is the kind of licensed, unlicensed, regulated work with asbestos is a framework which people are used to think for. How geological lab work might fit into this is extremely unclear. No license needed if the work is monitoring or ID of asbestos. No license needed if work operations are sporadic and low intensity. how do those things map onto geological lab work? And it seems to me this is where having some kind of formal guidelines document from HSE developed with us as a geo community is kind of essential in being able to demonstrate good practice and legal and regulatory compliance, because these things are not designed for looking at natural samples. None of the regulations, none of the laws were designed for looking at those. So working with little samples inside low negative pressure cabinets is okay. The issue then becomes how do we cut and grind and polish our polished in sections? How do we prepare our analytical powders? And this seems to me, this is the really key area, because these are the high risk activities which are likely to release fibres or result in fine grained waste products which might contain fibres. And this is the area, I think, which needs particular care and attention. The museum sector approach, which has informed us so far, has really been thinking about specimens sitting in drawers with not very much happening to them. And, you know, almost even an asbestos specimen sitting in a drawer with nothing happening to it in a card tray doesn't give off fibres. We did some monitoring of that around card trays containing asbestos. And, you know, it is activity that causes fibre release. And if that can be natural or man-made, but disruptive activities, rock disruption like this is clearly something where we need to think about these issues. What might we need in terms of knowledge and risk assessment and procedures and protocols to cut, grind, polish and crush potentially and actually asbestos form rocks safely in geolabs? We need, it seems to be information. We need information to see how different kinds of potentially asbestiform but not known to be asbestiform rocks might release asbestos fibres during actual processing in actual geolabs. One of the things it's thought to be very interesting to do would be to have a little kind of anonymised programme of dust from thin section cutting fines at the bottom of rock saws and crushing labs. And these doing that on an anonymised bay would be perhaps would be an interesting experiment to see whether these things are hazardous or not, or need to be classed as asbestiform waste or not, because we have no idea about this at the present. If we find that none of them are, then that seems to be quite an interesting and important find. If we find that some are, that suggests that it's something that we all need to take rather than putting individual blame on individual people. So that kind of approach could be an interesting way of developing our knowledge about this. How do we mitigating dust fibre release by wet cutting, grinding and lapping? Now this is actually what we do anyway by and large, and it is hugely beneficial, and it may be in itself sufficient for reducing airborne asbestos release from rock materials. Certainly the some of the Italian literature suggests that even where serpentinites and other things which did have chrysotile veins in them were being cut under water, the airborne asbestos around the plant was below safe levels. So, but the other thing is, if we can do that, you can do some things underwater quite easily, but other kinds of mass crushing process might be quite difficult or inappropriate to carry out underwater. And then you kind of think, well, if we're doing it underwater, how do we capture this wastewater and treat it and then dispose of materials? So there's an issue here. You kind of think, well, what about just having some special facilities, or we pay some lab to do preparation of powders and sections of such rocks, and then we can just work in our little benchtop units or with our equipment, and we can just do the little stuff. But this still begs the question of what such a facility would be like and how it would operate. And it seems to me, without any kind of open good practice guidelines, this is just a really kind of asking for people to take your money and charge you the earth for doing things without actually knowing what their good practice is. The ultra clean lab approach, it seems to be, I think this is potentially the way forward. But how we identify what processes need what kinds of approach, and how you consider the cleaning and decontamination of equipment, the fines and filter disposal, and what happens if equipment needs to be maintained and repaired, etc. These are all kind of issues. And these might be issues that, for example, people who are selling rock crushing equipment would also be very interested in, because if they can produce equipment which is safe in terms of its ability to work with these kind of considerations, that seems to be a very useful and important thing for them as well. So it may be that there is involvement from the people who make and sell rock cutting and crushing materials in terms of thinking about approaches which can encapsulate the area where fibres may be released and make that easy to clean and manage. And the key thing is, I think this needs to be a community approach. We need to share data, we need to share experiences, we need to share expertise. I know actually that an experiment has been done, at least one, on geological lab preparation of rocks involving chrysotile and actin-like bearing serpentinites, I think. And my money was putting into doing an experiment, and the experience with the experiment was found that actually the normal practice in the cutting room was sufficient to ensure no airborne asbestos was an issue. But that information is apparently they're not happy to share that. And it seems to me this is an enormously big problem, that organisations are so afraid of the A word that they won't even share good news, if you like, let alone bad news about these things. But it seems to me openness and clarity are the only ways of doing this, really. And I think getting together to gather useful and potentially useful information and experiences, published and unpublished, and collate those and identify key common good practice threads, working with health and safety regulators, and who actually are very hard-nosed people who are driven by data, facts, and epidemiology. You know, they don't want to waste money on zero-risk activity, complicating zero-risk activities. They want resources to be spent where it is going to have the biggest benefit in terms of people's lives and health. Where there are identifying gaps, where there are gaps in what we know, find out whether we need to address these and how we might get resources to do those. And that might, involve having some kind of research group, some collaborative grant application to work together to gather information. But it may be that the information is already out there. It's just been very, very, very hard to find so far. Review and analyse all of this, prepare draft documentation, circulate that for review and comment among the wider geo community, and particularly the kind of mineralogy and geochemistry community, who are mostly involved in rock crushing and these other things, and with health and safety people, and then work with your regulatory bodies such as the Health and Safety Lab to come up with to get their stamp on good practice guidelines. Now, I think that needs to happen. The big question is, how does it happen? And who does it? And how do we get the resources? As I say, the issue that happened after our 2015 meeting was we all had great intentions. We all had identified more or less these same issues. But no one's working life allowed them to make it a priority. And it seems to me, without having at least some people who have ring-fenced time, resources, and allocated budgets, this is not going to happen. And I think the question for us now, in some ways, is how do we put that together? How can we assemble these things together to deliver these kind of outcomes? I can't do this. I'm a retired person. I live in a place with terrible transport links in the Isle of Mull, and I have no funding, no resources, and it seems to be I'm happy to help with such experience as I have, but it seems to me this is something that the sector itself needs to address. And people go, oh, what about resources and so on? It seems to me the resources that are needed to deliver this are much smaller than the time and resources that are going to be spent agonizing about not doing it and the problems that will cause in the long term. And the necessity to be able to work on the full panoply of geomaterials that make up our planet is such a basic part of geoscience that it seems to me resourcing proper good practice development in that has to be cost effective. Anyway, over to you. Any volunteers to lead and develop that?
You've got one volunteer, the HSE Science Division. There you go.
I mean, I think the thing, first of all, is well, if you can identify some kind of questions. There are a lot of people here with a lot of relevant experience. As I say, Laurie Davis from the Health and Safety Lab is here, and with some of his team, I think. And there's a lot of goodwill in helping to make this happen. But as we found last time, goodwill by itself isn't enough. We need to make this, as I say, give some ring-fence time to some good people to put this together and do it right.
Perfect. So, John, could you remind us, where are we now in your programme? Have we moved fully into questions, or are we...
We're now into the Q&A section.
We're
yes,
into the Q&A. Okay, yeah. Perfect. Sorry, thank you. So there's lots of comments, certainly, and there's definitely some questions in here, but I'm going to start at the top. And I think it was Jens who had the first question. I'm sorry, let me just find it. Sorry, lots in the chat, which is great.
I can read that. I can read that out, Emer, if you like.
Fab, thank you, Kevin. If you found it, I haven't yet. I've started them.
There is a research exception in the UK control of asbestos regulations, but it's a bit of a grey zone. What will class as research? For example, would a company-sponsored research project apply?
So that's interesting. So where does this exemption apply?
Jens, do you want to unmute and talk to John?
I have read a research exception in the regulations. So there's obviously regulations in how you work with asbestos, but there is a specific exception in the regulations that I've seen. It says a research exception in how you work with asbestos, and it's related to whether you need UCAS accreditation to work with materials that contain asbestos. So that's a specific exception that I've seen now. But
okay,
obviously, it's great for research, but if you have a knowledge transfer partnership or anything like that, then it becomes a little bit of a does it count or does it not?
Yes, and I think it's a little bit like the naturally occurring radioactive materials exemption. Having an exemption for materials doesn't stop you being required not to irradiate people in the building or not to release asbestos from a naturally occurring sample. So just because you're allowed to do it doesn't mean that it is necessarily safe to do a particular thing with that specimen.
No, absolutely.
Yeah.
It's all about keeping our workers safe and healthy, of course.
Yeah, no, I mean, exactly. Yeah. And I think we lack the data on this. This is what seems to be. But I think it looks to me around the world that there is a lot of papers published on asbestos, and there must be a lot of university and other labs where people have worked with these things. And I suspect if people were willing to share some of those experiences, a lot of what we think we don't know, we'd find out we might have some good data on.
I fully agree.
Paul, I don't know if you wanted to comment specifically on that.
It was a specific comment on that. I'm seeing a nice picture of canoes. I wrote the Syria guide on asbestos in soil and made ground, which provides some help as to how to implement the HSE ACOPS, the approved code of practice for asbestos. I'm just intrigued by the word research, because there is a recognition that you are not working with asbestos, which then triggers the control of asbestos regs, if you're investigating. But once you know or suspect that asbestos is present,
Yes.
then, as the questioner said, you have a duty to protect your workers and prevent exposure and minimize the spread of asbestos. So I just didn't want people to walk away from here with the idea that if you're doing research, it's free for all. The University of Birmingham famously was taken to court over a PhD student investigating the speed of light. Sadly, the student got mesothelioma. So there are cases where research-related mesothelioma has resulted in legal action that predated HSE 143. But I think it's the investigation where you don't know that you have asbestos there, where there is a degree of flexibility, let's say.
Yeah, no, I mean, I think one of the slides I showed earlier, the identification of asbestiform materials was something that is recognised you have to do until you know it's asbestos. The asbestos regulations don't apply. But
John, that's not strictly true. I'm a geologist who goes out and does site investigations, and it is legally impossible to identify asbestos in the ground. It has to be done in a laboratory. But if I find stuff that looks and feels like asbestos, I treat it as if it is.
No, exactly. That's your training and experience enables you to make informed decisions. If you're not informed, you can't really operate safely. And it's, yeah.
Great, thank you very much, and thank you, Paul, for contributing. Martin Saunders, would you like to read your question, or would you like me to read out your question? I can go for it. I'm not sure if Martin's here. So Martin wonders, would it be worth involving engineers from the metallurgical or processing professions, who will, of course, have working knowledge of crushing, filtration, separation, etc., including dust suppression? Sorry, Martin, there you are now.
Yeah, sorry. It's I was trying to turn the mute off. I'm not used to Zoom. We work on Teams all the day.
Don't worry.
So yeah, it's something that having worked on the industrial geology side back in the 90s, there was an awful lot of work done in these areas, and those are very controlled methodologies that I'm sure they'll have an awful lot of information in there, and being as they've used it for so many years, it'd be worthwhile getting their view when we're looking at it on a much smaller scale.
No, absolutely. And I think the things that industrial operators have, which are particularly relevant, is not just the kind of, if you like, the filtration approach, but how they dispose of filtrates and cutting fines and all of the other materials that go along with it. So as I say, I have no doubt that there's an enormous amount of useful information out there. How it applies to quite what we do in the lab, you can only gather on you have to look at each individual case and see what was going on. But it seems to me currently, if you do a web search or something, you don't find most of that information at the level you want. Therefore, gathering that requires someone with time and contacts to use human approaches to get hold of that information, to get agreement to share it or use it, anonymized or not, and that in itself is a job, it seems to me, that would be extremely useful.
I agree.
Paul or Laurie, would you like to comment specifically on that?
I wasn't going to comment on that. I was going to comment on something else. But so if Paul wants to talk about that, then that's fine. I'll wait for him.
No, Paul is just tardy in taking his hand down. Hello, Laurie.
Okay, perfect. So Laurie, if it's not on this specific topic, do you mind if we keep just going through the list, and then either you could type it in or we can come back to you at the end?
I guess it's something that John's already covered, but yeah, I can come to it at the end.
Perfect, thank you. So there's a question here from Revan, who's a PhD student at BGS, and they're wondering, do you think there is still an asbestos risk in weathered soil materials derived from serpentinites and other ophiolite-related rocks, which of course is very relevant to a lot of people who have boots on the ground?
Well, I mean, the short answer is I don't know. I would actually say that if there is, it's probably not very high, at least in the UK. There is some epidemiology of natural asbestos, partly natural and partly mine waste in very small operations in California.
Yeah, so I know that Revan's work is Philippines based, if I remember correctly, Philippines based. So I guess you're talking about quite different climatic conditions there.
Yeah, and I think in arid climates, and certainly if you have amphibole present, that may be an issue. But again, for example, at Thetford, the risk seems to be rather low, and I think it is again related to general dustiness. But there are other factors at play here. One of the interesting things about the Western Australian stuff is because Western Australia has such a long-term, really deeply weathered regolith, the surface asbestos risk in a lot of the ironstones is very small or zero. But as they dig down below the weathering zone, amphibole survives. So even though we think of these amphiboles as being very persistent and long-lived, given suitable weathering, they do break down. So I think having a general statement as to whether they're risky or not is difficult. I think if you look at the epidemiology of in a serpentine area like the Lizard in Cornwall, or other places, I don't think there is, I'm not an expert in this, but I don't think there's overwhelming evidence that there are big lumps of asbestos disease associated with those outcrops. So, or even small lumps particularly associated with those outcrops. So I think by far the biggest risk is from identified industrial sources of asbestos. But these are things we don't actually know particularly much about. And I think, it's something which, I mean, Paul, you may have done work on soils and that kind of soft material. I'm a hard rock geologist rather than anything else. But so there may be some knowledge about this, although I suspect there are very few places where that kind of industrial remediation would have been carried out on a serpentine soil.
I think it's more like the
don't know.
like the lateritic development on top of serpentinites, where you get that kind of thick weathering crust and things. I don't know if Jens.
Laterites would almost certainly break down almost all silicates, so you're kind of you're going to get secondary things. So but again, I don't know off the hand about that.
Jens, I don't know if you have a particular comment on that.
Well, first of all, I could comment on, I guess, that I think the horizontal rain is driving away any asbestos risk. So yes, we have worked on gasserites in places like Turkey and Greece, where there's definitely been asbestos present in small amounts in the soil above. They tend to be associated with the lower levels, so basically the sap rock and the sort of saprolite horizons within the gasterite. But you certainly can't rule it out that it will be there in a sort of serpentinite-derived soil.
Or in a serpentinite rock.
We have another question from Simon. I don't know, Simon Cuthbert, if you would like to read it out, you're welcome to, or ask it, or I can, whichever you prefer.
I can do it if you like.
Great.
Yeah. Hi, John.
Hi, Sam.
I'm wondering if there is, by anecdote, rumor, or proper epidemiology, a known public health anomaly among rock prep technicians, particularly people who work in kind of dusty environments like thin section labs or rock crushing labs. I mean, is this recognized as a problem?
Again, the short answer is I don't know, but it is a question I asked before, and I have it, and Laurie may be able to provide a little more information on this, more up to date. But I think there is not good evidence that there are outliers associated with particular occupations of asbestos disease other than known sources that we have at the present. Now, that doesn't mean there's no risk of that, but that does suggest that it's small, it's there. Laurie, do you have anything?
Yeah, that's just I asked the HSC epidemiologist about this, and we don't have the granularity in the data to be able to identify such a relatively small group of workers, which will be the geological laboratory technicians. So there's no obvious spike that we can detect. It doesn't mean that there's no disease there, but if there is, then it's very, very small numbers, and it's not standing out as being significant. So unfortunately, we can't drill down to that kind of level just to kind of focus on that. But John did ask me that question, and I tried to find out.
One thing I'd comment on this is it struck me that I've got a fantastic video of a ornamental serpentine worker on the Lizard in Cornwall, taken in, I think, the 1920s, a black and white film of this guy turning serpentine on a dry lathe to make a lighthouse, which was a kind of common tourist thing that they sold. And the dust coming off this the serpentine is absolutely chronic. You know, it's dry cutting of rock with a lot of people were involved in the ornamental serpentine trade in the past in Cornwall. I think there's not very many now, but it would be interesting to know and perhaps look at I don't know whether it would be possible to take a retrospective look at the epidemiology of the Lizard serpentine workers and see whether there was anything there. Certainly there's nothing has ever been kind of emerged as being obvious about that kind of risk.
I suspect that part of it is just, you need a name or a category to put the data against. And if nobody's recognized that somebody is that kind of a worker, then, the anomaly won't show up. It's just simply not recognized as a sort of category of category of worker. So perhaps in the meantime, you have to take a precautionary principle and start asking those people without alarming them too much.
Yeah, I mean, it seemed to be as a kind of social history project. You could almost do a kind of oral history of relatives in the Lizard, and find out about the health effects that people experienced who were working on these kind of things. It would be interesting to know, because certainly the dust exposure they were getting from serpentinites was way ahead of anything anybody would get in a lab. And it's like...
The comment that Batsy's mentioned there is that you could also include the Portside marble workers. So there are probably people or workers previously that would have worked with this sort of stone that could potentially allow you to disaggregate that data a bit better. I think the final question that I know of is Laurie. I think you had a question. But before we come to that, John, I need to leave for this event, so I'm handing over to Kevin. But I wanted to thank, on behalf of MinSoc, I really want to thank you for what genuinely has been a fascinating and really interesting discussion and presentation. And it's so nice to have such engaged chat. I have collected all the resources that have been put into the chat so far. So thank you to anyone who's popped those in, and I will send that to Kevin, who will circulate it to the participants. So I'm going to hand over to Kevin now, and it's Laurie who's asking questions next. Perfect. Thank you.
Cheers, Emer.
See you. Bye.
Thanks, Emer.
I haven't really got a question. It was more going back to John's kind of call for people to put themselves forward to try and resolve the issue. So if the presence of HSE in this kind of group is a bar to others joining, then I will happily step back and let you get on with it. But I would really like to like us to be involved, because it is a subject that we know a lot about, and we obviously have a massive interest in it. That was all I was going to say.
I would just like to say I found working with Laurie and the people at the Health and Safety Labs and the HSE people who came to that workshop an excellent experience, and I really would encourage that their involvement should be seen as a huge plus and an asset for anyone else who wants to be involved in this. And that's my personal view.
Thanks both. If I can jump in here, I've heard a number of people wave their hands, including Paul, who's about to come in, and I suspect saying the same thing. I'd be glad to try and circulate lists and to facilitate a gathering of people to take this forward. I know you've met before and worked together before, but if you think there's mileage in doing that, I'd be happy to try and coordinate.
I think that would be very useful. I mean, I think otherwise we need to find a way of finding some ways where some people are going to take some of this forward. And this meeting is not itself that, but it seems to me, I hope we can perhaps get out of the people who are here and people they know, we could perhaps find a group that would do that.
Okay, I will create a mailing list for everybody. Paul, do you want to jump in there?
I was going to say two things, really. Firstly, Laurie, we really would value so much you and HSE, HSL more generally getting involved. My experience with you and your colleagues has been you will bend over backwards to be helpful and only get enforcement-y types when people are misbehaving and definitely not trying to follow the rules. So I don't see why anybody would be sensitive to that. I think a collaborative approach where we have a document that we can all work on together would be a time-efficient way of doing it. And I think there are lessons to be learned from some of the commercial laboratory approaches to handling samples. I think, as John has excellently illustrated, it's a really important thing to do, but it doesn't have to be a hugely onerous task. So yes, the idea of having a shared mailing list where we can collaborate would be a really good way forward. And I can certainly bring my own expertise on risk assessment and also contacts into the commercial labs who have to do these things to bear if that will be of use. But thank you, John, and thanks, Laurie, for your very kind offer.
Yes, indeed. We have a couple more questions. I know we're coming to the end, and we promised to be done by 5. Mike and Jens are both asking about why workers on these dry lathes, as you described them, illness in those communities. Why wasn't that flagged up when it happened? And I think John answered that point earlier, which is that a lot of the time the illness didn't occur until much later on. It wasn't an instantaneous reaction thing. John, is that correct?
I mean, I just don't know anything about it. I mean, I don't recall. I mean, even in Hugh Miller's time, for example, and to take a thing, silicosis and was known as a problem for stonemasons, particularly in Scotland, because the weather was terrible and they worked in wee sheds, so there was a lot of dust. Whereas in England and sunny places like that, they worked more in the outdoors and there was less issue of silicosis. So dust associated with stoneworking was known to be a problem, you know, in the 1850s, 1840s. Before that, I've never read anything that said the people who made ornamental lighthouses on the Lizard all tended to die of lung disease. You know, that is the basis at which my current knowledge is. So I think it wasn't obviously associated with poor health in any of the accounts I've read, and I've got little booklets about the history of serpentine thing produced in the Lizard and so on. Partly because I like the use of indigenous stones as ornamental materials. But it's we don't know at the moment, but it seems to me it would be possible to do some experimentation there, or some exploration there.
Okay. Laurie?
I was just to add a little bit to what John's just said about, so the published HSE statistics on asbestos-related deaths, whether it's mesothelioma or asbestosis or lung cancer, are all based on information from the National Statistics kind of Office, and the job title of the person is taken from their death certificate. So whatever's recorded there is what goes into the database. So if that isn't recorded very kind of detailed or very accurately, then that doesn't get that granularity doesn't get transferred into the database. So in many ways, what we have to analyze is just something that's recorded by whoever writes out the coroner or whoever writes out the death certificate, and we can't get to that answer using that route. We'd have to find it through a different way. But there are other alternatives that we could try if someone was really interested. But it's something I'm happy to talk to about offline, but not necessarily here if anyone's interested.
It seems to me if we have a group who are interested in taking this forward, that would be a forum where perhaps we could look at ways of gathering data from currently inaccessible sources like that.
Very good. Folks, I don't have any more questions with stars on them. If you feel like you've wanted to ask a question, but I haven't called you out yet, or Emer didn't, do you want to just put your hand up and we can do it now? Otherwise, what I will do is say thanks again on behalf of everybody to John for the excellent talk this afternoon. It's been really, really good, really enjoyable, and I think it doesn't end here. We will have more to do. I hope that many of us are less bewildered than we were before, to use your own phrase at the start, John. I think we've all learned a lot today. So I don't see any other hands going up. So thanks again, and we'll be in touch.